Thank you, Dave, for having me today. It's a pleasure to be here. Thank you all for coming today to see this presentation, this short, small thing. Today I will talk about collaborative teleoperation of a robotic fleet. At the moment, system is still in development, but I will show the main key points, like what it's capable of and why it's important to move into this direction industry-wide. So I call the system Hive, with like relation to the beehive, as there is a hierarchy of controllers and workers, and we will come to this in a few slides. So I was kind of surprised when researching the market for this particular niche of teleoperation. The market estimate for teleoperated vehicles is somewhere between, so there are multiple estimates, somewhere between 2.5 billion and up to 171 billion United States dollars by 2032. So in like 7-8 years, we will get there. In contrast, the humanoid robots that we mentioned just a couple of minutes ago before we started this recording estimated about half of that. And that was a great surprise. So I want to build a system, as I already said, for multiple people to be able to control in real time a robotic fleet, to have telemetry data, to have video data, audio data, and see what other robots and other members of the group are doing with the robots. And with the prototype that I will show now in some minutes, I tested with my friend in Kiev. We got sub-second latency between robot and operator. While robot at my place in Italy, operator, my friend, was in Kiev, and distance between the two was about 2,500 kilometers. We got sub-second latency of controlling that. It's incredible compared to other teleoperated solutions. And in addition to that, a system that we will see in a bit allows multiple people to see that, multiple people to have sub-second latency of entire fleet. It's, imagine like a Google Docs, but for a fleet of robots, like fleet of city transport or taxis, which could be controlled from many places simultaneously. I feel this is the future where we go. A little bit of history. The main question came when I had a discussion with my friends who serves now in the special military operation forces of Ukraine. He mentioned that in some occasions they are not allowed to have additional people in the group, and so they are not capable of having multiple surveillance drones. In particular, my friend mentioned like reconnaissance groups where there are very few well-trained, dedicated people who perform certain operation, and they use drone with camera to observe the location. My friend told me, like, if we would have like 2 or 3 cameras, we cover two times larger area, or like 3 times larger area. That would be like not even incremental boost in our productivity. That would be virtually the next level of how we operate and how we do our things, how much time it takes for us to do certain things. And they are so limited because every remote controlled drone requires a human operator. So during the operation, the person, let's call it, disconnects from the reality and connects to the drone with the virtual reality glasses and flies the drone. A person is not able to like see what happens around. Is very limited how fast it can react to the environment, like move or hide or start driving or other things. Another very big limitation of remote driving in glasses that I heard from my other friends who are instructors of the FPV drone users, and I found references online for this, is the VR motion sickness. So it's a physiological phenomenon because divergence and accommodation of our eyes misalign with what our brain used to have when watching objects at different distance. In a VR, all objects are at, let's call it, same distance, because our eyes are focused on the screen, which is several centimeters far from them. This causes conflict, and many people are actually start feeling sick in 15 to 25 minutes. And the fact is that a friend of mine say that only 1 out of 5 people who want to fly the drone can actually fly it. So many people just getting sick and cannot do that. That's not a problem. So I came across the internet and searching for the solution, and state of the art, essentially, okay, remote control. It could be a computer with the remote or a joystick or AR glasses and a particular device, like a flying drone or a robotic car or an excavator. There is incredible prior art reference which came out like maybe 2 years ago or so in China. In one of the large container terminals, they automated the container cart, so vehicle that moves the container to its destination, and they automated the lift grants that picks up containers and load them. But still, there are people with multiple screens all over the place, with joysticks and with a console of buttons. So one guy is driving one container. That still doesn't scale much. With all the automation, with all the AI and sensors and radars, lidars that we can put on the vehicles, I was surprised that those things still collapse, stop working out of some, I don't know, internal problems. So there's a large room of improvement here. And I believe it's not really possible to solve these solutions without human intervention in many, many cases. This year, there are a lot of startups in London focused on logistic hub automation. They claim they will build AI and sensors and tools for robots to navigate autonomously. I don't believe that. Forklifters still collapse, still crash and cause damage. So that's unavoidable in some sense, because environment is complex, environment is changing, and each particular AI algorithm that has been trained on a given data of a warehouse, after half a year or a year, the same warehouse will look different and AI algorithm will fail. I would bet that not many systems are capable of updating the algorithms on the fly, because it's yet another technological challenge we're about to solve. Okay. The other prior art is the like a programmed drone show flight. I looked it up online. Most of the companies either provide this as a service, so they create the hardware, they set up the software, their personnel comes on site and performs the drone show. Some companies give software, but I found nothing accessible without programming knowledge, so people can plug and play their devices. They would still require programming, they would still require a license for the software. And chances are they will require custom hardware, like custom radio communication tools for those drones, or processors, or like camera or other types of sensors. So it's, at least I didn't found the solution which could integrate fully customized device or a vehicle or a drone. And my proposition is to build a system which would allow, so first it would allow to connect custom devices. It will allow to have a unified and well-documented and I hope easy to use interface. So with very small initial training or no training at all, a person could use the system without need of programming the operation of multiple robots together, like programming the flight, let's call it this. So the person like point and click, and those devices will perform the function. So here is sort of a cartoon with the several flying drones, screen showing like a 3D model of that, and the user selecting one of them and assigning new geographic coordinates. And as soon as I put together the slides, I put together this particular slide, I came to realize that any number of any vehicles could be controlled by any number of users, like in a computer game. I apologize for bad quality of these images, but I think they show the message. There are multiple things of different type and multiple people controlling them in real time and are getting updates in real time. So this is the sort of my inspiration from nature, where bee colony is organized in hierarchy of a queen, controlling the nest, the workers, and the drones. And as a result, working together, they could build things and produce honey. So here my sort of a reference, like a human operator controlling multiple different things to build a city, essentially, like a nest for. So one of the non-military examples I want to talk a little bit about, I'm not going to spend much time on it, is semi-automated construction site. there are multiple vehicles, multiple because some tasks at the construction site performed only by human, other would be partially automated, while something else could be completely automated. So the cartoon in the center shows sort of a camera view on the construction site where ground, several like excavators, workers shown. And on the right is the cartoon of the map view, how it could look like on the operator screen. So all the units are positioned relative to each other on a map, presumably. They could be operated and they are updated in a real time, like with the location and the status. So like a operator of the site could see where his people are. If someone is driving that truck or just left the truck in the middle of the construction, and it's better to call somebody to pick up the truck and move it away. So it allow other trucks and people to pass by. And there could be multiple people supervising different parts of the construction site, presumably. So this scenarios is like simpler in some sense. What we have here is how I would imagine security patrolling the perimeter using the two drones with camera. So there's a map view showing them the status and the direction and the live stream of each of them. If there is a system for autonomous flight, the operator could assign one of the drones just to follow another one and fly only one of them, while other drone will follow at a certain distance. This could be interesting scenario for some operation that I heard of. And well, essentially everything I talked about could be applied to many aspects of business and what we do in general. It could be applied to Cosmos, could be applied to excavation of minerals, to construction, to healthcare. And I probably already mentioned, I talked with the people who are doing robots for healthcare. They say it could be interesting to see this live and integrate two systems at some point. It could be automotive, logistics, security, cinema, and well, and entertainment, of course. And this may sound naive, but I will consider success if we will mine asteroids using this sort of system. So this will constitute success for me, that we are controlling things in space to do something useful for us. So enough talking. Let's move to the fun part. So what we have here, this is the regular Google Maps. It is three-dimensional. We could turn satellite view if we want. So it's a normal Google Maps that we used to. And at the moment, I have one item connected to the system. Let's call it a robot, which is a web camera mounted on a servo drive, which sits like a couple of meters in. Let me know, Dave, if you want me to zoom in to have slightly bigger video. Probably I will do that. Oops. Okay, that's better. So that's me out there. This thing has two options of control. I can control it just pressing buttons on the keyboard. I don't know if you can hear my clicks, but I'm just clicking on the keyboard. Or I can click on the map what to do. So the position of click getting geolocated and sends coordinates down to the computer of this robot, computes the angle on which to turn. So now I want to make it more fun. And I will use a robot car. So I will stop sharing for the moment. So here it is. Sometime later, if you want, we could discuss the hardware, but that's not the main point. Okay. So I take this and I will place somewhere in the room. It takes about 1 minute for the controller to start. And at any point, you can go to this website and tell me if you see this more or less the same picture with video stream, buttons, and the robot. Because I want to make assessment. Okay, here we go. So they're very close to each other. That's why we have them intersect. Because I want to make assessment how much quality degrades if we are further apart, further away from the robot. Because now I am accessing them from my local network. Essentially, video goes only over the router. We'll return to that. Okay,
so
selected.
are you looking for a volunteer then to get involved in driving?
Oh, car works. So essentially, every time when I click on the map, the car rotates. So now I will just drag. Okay, it's kind of too much. The video quality of the car is not the best. The controller there is not the most powerful. Let's drive. That's me. The user interface is still in development, and the scale of the movement on the map on a turn map is it's still not adjusted very well. So now I select two of them, and let's see if they can move together. And they are. Let's hope I will not break anything if I. But it's fun there. It's a lot of fun. Okay. Fine. Yeah.
Hey, Sasha, do you want to talk a bit about the implementation details? How obviously it involves Google Maps, but the rest of it?
So the entire stack from the microcontroller firmware in C and bit packing for speed and direction of movement up to the front end in TypeScript. So on the robot, but let's start from the robot. So on the car, what we have here, it's the orange Pi 2 with the Wi-Fi. It has like 1 GB of RAM, not that much of compute power. So this guy here is the orange H616 processor. This guy here is Arduino Mega. And this guy is running video streaming, a data channel to tell this guy what to do. This just turns wheels. It doesn't do anything fancy or complicated. So there are 4 DC motors controlled separately, and somewhere inside we have a motor shield. So it's pretty basic, I would say, toy. For streaming everything, it uses WebRTC, which is like a industry standard for peer-to-peer communication. Essentially, what happens there when things go online and like someone opens a browser window that supposed to stream video or receive a video or data, it talks to what's called turn server to tell about where it is in the network. And the turn server then tells all the other things connected to it, because like multiple users come online, talk to the turn server, and in turn spreads the information who is located where in the network to everybody. And then when the particular peer receives the information from the turn server about other candidates, it decides to whom connect and what are the properties of the connection. This happens over the signal server. So there's like another instance running that manages communication between the different peers. After the communication is done, they know the direct, shortest possible way in the network for them to communicate. They don't need any server. They don't need any further like agreements or communication with third parties. They talk directly to each other over encrypted, essentially SSL tunnel. And what I mentioned earlier today, that we discussed this with John. He works with the networks and video a lot, and he was very skeptical about the technology of like, could those devices actually talk to each other directly? Like, probably not. Probably they're still going through some server or at least a network like nodes somewhere outside of your home Wi-Fi when you are testing. So what I did, I connect the stream. So I opened them up, the browser that will receive the video streams. I started the two robots that will send the stream, and I disconnect my home router from the internet. So only local home Wi-Fi is available for them. And it all worked fine. So it turned out it actually peer-to-peer, which I was also surprised to see, because I expected something will be missing there, something is not going to work, because usually in the documentation people list many great things, but those things sometimes don't work in all scenarios, all setups, and you end up with the regular system where information goes server, the server goes back to the recipient. That's not the case.
Oh, okay. So it's kind of, so you've got like a kind of agent client server sort of like an agent-based system, right? So it's kind of sending the packet directly from one agent to another. Ah, okay, right. So you don't have okay, that makes sense. Yeah, yeah.
I had a discussion with other hardware colleagues. They are using the robotic operation system too for creating the, again, agent-agent communication. They also run into the same issue that it still requires a master node on the known IP address for messaging or routing the messages. What they wanted at the time, agents talked directly to each other because the master node would be unavailable. They were thinking about like consensus, so if agents don't have a master node, elect one of the agents as a master node, something that gets really complicated when you go to the implementation details. On the cloud and backend side, what I have two virtual machines in the Google Cloud for the turn server and signaling server, and I have this managed service called App Engine for web application, which essentially spawns a small Kubernetes cluster and set up load balancing and CDN cache for requests on the user. So the website hive.demo.freerobotics.com served from the App Engine. REST comes to virtual machines or implemented directly on the robots.
Interesting.
On the front end, side. It's a Google Maps API, official one, with 3JS. It's a library for drawing the three-dimensional things in the browser directly. And this portion of WebRTC client added. So the web page could be a WebRTC peer to communicate with others. And essentially, this page has a WebRTC. And why robot is so slow? Because it's running a web browser and opening a web page and starts streaming video through the web page. As if it's another person turning on their like Google Meets meeting or something. So that's probably why it's so hard for the car Orange Pi to serve and stream video.
Sasha, could I just ask a question going back to
Sure.
The earlier part of what you demonstrated to us? I think you made the point that you could rationalize the number of people who actually have to be in the driving seat because you've got, if I understood you correctly, one or more other drones or robots who would follow behind at a particular distance the one that is being teleoperated, and so that gives you the efficiency. Is that right? So as you say, it's a swarm, hence the hive, the swarm, because they will follow the queen. The queen is being operated by someone. So instead of having to have multiple operators, you can have one because the others follow on behind. If you then want the ones that are the followers to take a particular action, what would be the steps you envisage at this stage to get them to do that? So other than just following, if you then say, okay, I now want you to do something, those other robots, what would be the process necessary to activate them to do something? Or would it be the case that, I don't know, let's take a silly example. Perhaps if you're a crop sprayer, and the queen is leading the set of drones across the agricultural plot and it wants to spray crops. If the queen started to release, say, the pesticide or something else onto the crops, would all the others then be able to be triggered from the queen to do something similar? Or would then there have to be a more individual intervention with each of the drones following behind the queen?
I see what you're saying. So you're asking if the logic of following could be interrupted with new data.
Well, yes. I mean, if you've got them following, but you want them then to take action, do you then need? Yes, I mean, basically, would you send new data from the queen, the one that's being followed, to all the other drones to say, take this action, don't just follow me? Presumably, it could be programmed to be sent instructions to comply with a call to action by the lead drone, by the queen. Is that right? Am I understand? Forgive me for my slightly muddled question, but am I understanding correctly from what I've said?
That's a perfect example of how the system could be used, because this streaming WebRTC protocol and set of libraries allow for everybody to everybody connection. So operator talks to the queen, queen talks to everybody else, and operator also can talk to each of them individually. So depending on a particular logic of what the swarm's supposed to do, it could be implemented that, okay, operator tells the queen, okay, start spraying, and queen sends down the commands.
Yeah.
So yes, that's a perfect example of layers of the responsibility in the swarm and top-down command control.
Yeah, that's great. Great possibilities there for,
Yes.
in that sense, as you say, the efficiency of operation, being able to use that delegated
Yes.
form of triggering action. Great, thank you.
Yes. At the same time, operator could have possibility to take on a particular drone and drive it somewhere else, or assign some other things to do. In a particular implementation that we see today, I disabled communication between the robots on purpose, so they don't waste CPU time on empty messages and keeping the connection open. And I disable video from operator to the robots, and I disable video between robots because I don't need that. But of course, it is possible to have. Everybody could be connected to everybody and exchange data between them.
And so in the same way that we saw the camera and the car cooperating together, let's just take another example. It was, I don't know, say the Boston Dynamics dog. If you have a lead dog running across a particular terrain with a pack of others going with that, lead dog could be the one that the operator drives to begin with, but equally you could cascade the message, do this, or if necessary, the operator could then take control of a particular dog within the pack and send other instructions to it. So yeah, a lot of flexibility then. So I say great potential. Yeah, great. Thank you.
So I had a question around how around the current research, because I don't quite know it, around things like collision avoidance. Because one of the things that I'm thinking of is, like, you know, if you're a pilot and you're an FPV, for example, if you're doing surveying or something like that, one of the things that can catch people out, especially when you're flying a drone, is things like unknown obstacles. So you can, for example, there's a rule in drone aviation is that you take 50 meters of the highest obstacle. So you generally fly 50 meters above it, depending on your qualification. And it's interesting because when you have a swarm, or if you're flying an FPV, one of the things that you are bound to is a controller. So you kind of see a controller, you say, right, okay, you know, I'm seeing a particular image, and you respond with an image. But if you're flying a long way away, you can't necessarily see the drone in your field of view. So that got me thinking, as you know, if you have multiple drones and you've got multiple directions to see at the same time, how do you sort of coordinate an action to avoid something like a TV mast that could be within your immediate vicinity? I don't know what the current research is on that. Can it sort of update in real time to say, right, okay, there's a TV mast, we didn't plan for it because we didn't know it was there, you know, and then can it avoid that particular obstacle?
So the research there is pretty advanced, and I feel like at the moment I don't have enough knowledge to implement something better. Let me take a look at example that was released a couple of years ago, but by I think 8 researchers in Asia somewhere. Let me find it. A couple of seconds. It is, when I first saw it, I was just amazed how good it is. Okay, this is something else. So what happens there is essentially they are flying the swarm through the bamboo wood.
Oh, wow.
Yeah, I want to show you this video.
Look at that. Oh, wow, yeah.
This is also something else.
Wow, okay, that's pretty cool.
Did Okay, where did I put that? here. Okay, I share my screen.
Wow.
So this was 2 years ago,
Wow.
and now it's
Really
even
cool.
better, I believe.
That's pretty cool. Yeah.
Sorry for the noise.
I mean, that is fascinating. And were they operating autonomously? Because it didn't
I
look as
think
though there
so.
was any single person controlling all those, because the fact that they are clearly sensitive then to potential obstacles, and somehow their programming enables them to be sensitive and therefore able to take evasive action. Is that right? Is that what it was showing? I think that's what I saw. And so presumably they were doing it autonomously rather than have someone operating all of them. Was there somebody operating a lead one, as far as you know?
I couldn't tell the details of the implementation, but definitely they were autonomous.
Yeah, okay. Very impressive.
So when I watched this video, I like, no, I'm not gonna jump into autonomous obstacle avoidance because people are so much more advanced than I am that I will just, no, there is no point of me going through all of this because people made decades of research in the field, and these are the results they achieved.
At least you can incorporate that. I mean, that's the point. You incorporate it into what you're doing. That's the idea, isn't it? These things are cumulative. Therefore, as long as you're not breaching any patented ideas, you could be able to build on that and then add the extra dimension in terms of the at a distance operation. Because that's the other thing. Here, presumably, the operations have been on people who are Wi-Fi to Wi-Fi, but presumably you could do it if you were simply operating, I don't know, via some satellite link or some other such device. It hasn't just got to be through somebody working within it. So, I mean, that's the essence, the real time, no or very limited latency capacity to hand over control between different people. And yet those different people, it's almost the idea of generals behind lines. You're sitting in your different command stations, communicating with one another and making things happen remotely with the robotic devices. That's a great potential. And if you can add to that the capacity autonomously to do obstacle avoidance, I mean, it's a bit like, Dave, isn't it, with the now robots, the built-in obstacle avoidance sometimes works better than others, but that's something certainly Aldebaran built in, didn't they, as part of their design? Certainly, with now.
Are you talking about the sort of, so it doesn't hit itself? Is that
Yeah, that's it. As I say, if it goes along, and because even some of the little pre-programmed things that you could download, he'd be wandering around humming to himself, and obviously if he saw a person or an obstacle of some other sort, he'd move back from that. So they clearly, long time ago, built that notion in using the inbuilt sensors.
Yeah, I think that they're just using the ultrasound sensors.
Yeah.
But I mean, you can get really small cameras now that do 3D, 3D, stereo 3D depth.
Mm.
And I've got a couple lying around somewhere, but yeah, they're sort of yay big, and they do the onboard 3D depth computation for you. So that would definitely help with things like obstacle avoidance.
I think you're on to a winner there, Sasha. It sounds brilliant.
Thank you. So now I'm thinking how to transform what I have. Okay, I have a map, I have connection to the robots, I could have connection between robots. How do I frame this particular technology stack into a specific useful product? Like, who could be interested in this? In using things we talked about today, because then I could focus on improving the reliability or improving the user interface or other aspects.
Is it the sort of thing, delivery type organization? I mean, for a long time, we've supposedly been going to get these Amazon drones, haven't we, coming and delivering, yet to materialize, certainly in my experience. But you've got something like this, that if you need people to do bespoke deliveries with, perhaps fairly small packages, but nonetheless being able to navigate through urban landscapes, and you've got somebody back at the control station doing that would be one obvious way. I mean, inevitably, and we don't want to go down this route, but they're going to be military cases that you could use this for. But yeah, I mean, who do you want to go with? Service operation or the military industrial complex?
There are a couple of startups already building remotely driven small package delivery vehicles, either like sort of tiny buses like Amazon things, or flying like hybrid schemes, semi-aircraft, semi-quadcopter or six-copter. But I didn't see the swarming there.
No, that's true. No, that's more individualized, isn't it? You're right, rather than the swarm. I mean, the swarm, I mean, that's why I came with the thought of crop spraying or firefighting or something like that. Imagine going into, I mean, the very fact that they just had the problems with the hurricanes in Florida, being able to send in a swarm to areas where people perhaps are stranded and need things, not just one person package delivery, but multiple people, or equally, if you're firefighting, something like that, seems to have great potential.
I was just thinking, actually, it's not, I guess, quite a swarm, but there's already in Cambridge, in the UK, there's some autonomous food delivery vehicles running around that I've actually I saw a couple roaming last time I was in Cambridge. I just put a couple of links there, but I wonder if there's something similar there, where you have these things mostly running autonomously, but you can then intervene if they have problems. Like in the second link, you see these two robots get in their own way, and they have this sort of stalemate where they kind of stuck because they're both trying to go where the other one is.
So do they blind each other, or what happened there?
I think they're both detecting each. I haven't finished reading the article, but I wonder if they're finished. They've detected each other as an obstacle, and so they're gonna.
So they got a deadlock. Okay.
What
Oh,
about
dear.
in sort of creative and sporting spaces where people need to have you know, you see an awful lot of drone footage these days with cameras, and in sports stadia, I don't know, major soccer tournaments, you've actually got things, haven't you, with cameras now sliding around on wires, being able to provide close-up detail of the action. If you could have something that was not attached to anything, but actually able to be a little bit like the director sits back and directs the swarm to go out with the cameras, and then real time being able to do as just like when people in television studios. I mean, once upon a time, I know you had the physical camera operators. These days, these things again, they're autonomously operated, aren't they? But if you could do something that's not just in a controlled studio environment, but actually being able to go out into open
Yeah.
spaces and have drones going out, enabling video photography in real time under the control of. I mean, the director becomes the kind of the queen of the queens.
Okay.
But I say that's just another thought.
Yeah, filming is one of the great areas because all the latest automation like things and breakthroughs are already in filming. Like Disney, instead of how to okay, so instead of hiring a person who will perform a dangerous trick, they build in a humanoid robot, or like 100 of them, and do them
They're doing the
make them
stunts
do
now.
the trick. It's called animatronics or something like that.
Yeah. Yeah.
That's also a possibility to find a niche in there.
Indeed, yes. Yes, that's perhaps why there's one guy I know works for Robot Lab, and it's a long time since I was chatting with him, but he was telling me he used to be a film stuntman, so he's obviously gone to work in the robotics world now, albeit in customer liaison rather than doing stunts. The robots put him out of his stunt work, so he's taking the job controlling the robots.
Yeah. So instead of being there under the sun or under the rain or in the cold, he's just in the comfortable office or like a control room, and the robot is doing what's supposed to be done out there in the wild. Yeah, that's essentially what's possible here to do. And also, I watch several like podcasts and read the paper about remote driving in the UK, and particularly interesting was that people like actual drivers who drive trucks or passenger buses between, I don't remember, like London and Leeds or something. So the drive is pretty long. It's longer than 8 hours from what they say. It's just physically hard for them to drive. To stay in the car for longer than 3-4 hours, because they have to have two persons. One drives 4 hours, then another drives 4 hours. But still, it's not ideal. It's like entire day in the bus. It's not fun.
Yeah.
yeah, I texted people who organized the like survey of drivers who drive long hauls, but I don't have answer yet. Maybe they'll answer sometime.
I was just wondering if you want some sort of hybrid mode, because you've got the map view, which I guess is good if you have the drones quite far apart. But I was thinking, you know, in something like your construction site example, you almost don't really want a map. You want maybe something like a SLAM, you know, like you have you're doing something like SLAM, so you put the drones around and they compute, this is my 3D environment.
Yep.
And you move around that rather than.
Yes, that's possible. That's
I mean,
like those drones on the video that I showed.
yeah,
I think
they'll do
they
something similar.
already do SLAM
Yeah.
and like point cloud optimization on the fly in some sense. So for particular use case of a construction site, that should be done. That's how it should work. One thing I heard from the startup in, I think in Berlin, they were building a recognition system, like a camera-based recognition system for personnel working on the construction site. They wanted to, exactly what you said, they wanted to track people on the construction site, who is where, and if they are equipped properly with all the hats, all the protective jackets, etc. And guys told me that it's quite a big problem to have a clear camera view on a construction site. So maybe moving camera could help, but there are already a lot of moving parts on the construction, so I don't know how good would be that, adding even something flying in there.
Yeah, I could see that you probably don't want something flying around construction workers, especially if they, that could be unfortunate if they're carrying heavy things, or something, they get buzzed by a drone. But I wonder if I wonder if you kind of you try and solve that by, you just have, okay, well, cameras are cheap. I just have loads of cameras on this site, and one of them will see a person, and you just you just build up a composite image based on, well, a composite model based on your set of cameras.
Yeah. Yeah, that's a good idea, because hardware is getting cheaper and cheaper over time. That's true. That's a good idea. Okay, let me copy everything we have here.
Yeah, it also makes you. Yeah, I'll just go further. Yeah, makes you think is, if what you want is kind of like, you have your 3D view is the interface of the custom, the operator's driving, and they almost, rather than having video feeds, they're basically, the cameras are being basically used to build a 3D model, maybe textured with the video parts of the video view, and you're just sort of kind of essentially doing it FPV through that, rather than looking at multiple video signals. That'd be a fun problem to build on that.
That would be an interesting problem to work on. Yes, okay. Where the point cloud has to be computed in real time on the drone, so it will have large processor, it will consume a lot of power, it will be big, so it will be a big drone.
I don't know, does it? Yeah, I mean, I guess, does it have to be computed on the drone? I mean, I guess it depends how comfortable you are with your sort of, your local network. You could imagine have some sort of your fairly beefy controller that as long as it's it's relatively local, but it synthesizes all the camera views and then sends back information to information to the drone, or simulates the 3D environment that the operator is using.
I mean, talking about that idea of building up a composite image using multiple cameras, placed in different locations. I wonder how things work at the moment on highway networks, where you've got lots and lots of cameras monitoring in real time the volume of traffic and also weather conditions, changing conditions. Is there something that is being fed back to some central point where people are then making decisions based upon the composite image as it evolves in real time? And would that be a way, as you say, the cameras are sort of statically located, you haven't got drones going, right? But if you've got them, because as you say, the cost of the hardware reducing all the time, lots and lots of those across a road or rail network monitoring these things. If you can get them operating in that Hive fashion, then maybe that would have some potential.
That could be something. That could be something that Ministry of Transport in Belgium and Netherlands, maybe in UK, in US, are already working on.
Well, I don't know, but yeah.
Because Belgium is pretty advanced. I saw the demo of a joint project between EMAC, the Semiconductor Research Institute in Belgium, and Ministry of Transport in Netherlands. Essentially for teleoperation, for what we talked about today. But because they are so big, they, as I said, they don't need to sell this to anybody. They created a university program and examples, built examples of how it could be used. So in Belgium and Netherlands, they're actually teaching students how to do this sort of things. And in their presentation video, they had a car driving driven remotely across the border between Belgium and Netherlands at like 60 FPS frame rate at like 4K video quality, which is technical challenge on its own. And when changing the mobile operator for the mobile network, they had just a couple of dropped frames. So yes, networks connect in advance, prepare things in advance, but still to implement all of that properly, to have such incredible latency for such a huge color stream of 4K video stream from the car and comments from the operator back to the car. It's yeah, it's something that like government could do.
Yes.
Okay, so I think we are on time perfectly. Any closing thoughts, Dave?
No, thank you for the demo. I mean, it'd be I guess maybe in a few months, maybe we could do a round two. You can see how much progress you've made. I guess maybe a quick UI change to have different colors or different symbols for each of the types of vehicle would be
Yeah,
good thing. Sorry, Steve. I was just also digging out the video, your Tesla robotaxi event. It seems like it caused a drop in a 7% drop in the Tesla share price.
I saw that in the share
So
price.
yeah, not the unqualified success it could have been.
Interesting. I mean, why do you think that would be? I mean, I've only just seen that today, and I thought, okay, is it something to do with they're not very impressed about the rate of rollout or something like that? I don't know.
I just skimmed the article. It seemed to think that basically it was it's a bit vague on details and timelines and
well,
yeah,
Elon Musk did say at one point, so I have been known to be a bit optimistic on timelines. So he's sending
you think?
Right now, but say that again.
I think he's also been a bit stretching the truth around capabilities of self-driving. Like, yeah, full self-driving exists. Yeah.
Well, it'd be interesting, wouldn't it, to interview all those people, because I mean, I'm sure it was an invited group, but there were a lot of people there, children as well as adults, and it was said that there are enough vehicles that everybody present will get a chance to be driven around the lot. So I don't know, it'd be interesting to see what their feedback is from that hands-on experience. Who can say?
So we need more cars.
Yeah, we need more cars. We need more powerful computers and good cameras, good fast cameras.
Yeah, I mean, I guess there should be WebRTC servers, right, that don't require running Chrome.
Sorry,
So I think you said that the car streaming the video was actually running Chrome in order to stream RTC.
Yeah.
Yeah. So there must be native libraries where you don't need to run the browser to stream the video. Right?
Well,
Selenium.
I don't have. Yes, there are native libraries. They has to be compiled for a particular setup for a particular device, while companies like Google and Mozilla Foundation are taking care about their browsers being supported on virtually everything.
Oh yeah,
So-
yeah. I take that point. It's just that you mentioned like like if you want to run it on slow hardware, then yeah, I guess you need to slim down maybe not run the browser.
Yeah, that's true.
But
I made a decision to go for a browser because last year I've tried to do the same thing with the like native libraries. I had GStreamer, I had OpenCV frame grabber or something like that. It didn't work. Then I choose V4L something frame grabber for Linux. It gave like 20-second latency for a video, and I was able to get to like 10 FPS. So it's probably my skills. I cannot set up those properly. I've tried for half a year and it didn't work well. So I just abandoned all of that and decided, okay, if I could have a computer that can run a web browser, I use that as a black box and I put my trust on the corporation that created a web browser and troubleshooted all the streaming, buffering, packaging, coding, decoding, and everything related.
Oh yeah, I mean, I'm not looking the idea of doing the simple thing that works. Yeah, I wasn't intending to knock the work you've done. Just thinking of yeah.
No, I've tried to follow the path of optimizing myself libraries for native. It didn't work over 6 months, and I decided just stop this activity.
Sometimes you've got to cut your losses.
I've started like browsing because I'm getting curious. Like, there must be a way of doing this without a browser. So I started looking at a few libraries.
Yeah, so I know people who work with the streaming and they have it really fast and efficient, but it took them quite a bit to get to the level of required capacity and required frame rate and buffering.
Yeah, I mean, I know people who've been doing streaming video from the now, and they just use GStreamer, which is I don't know. I don't know how well that really works, but yeah. I've been thinking it's something I've been thinking about because I'm working on an application that needs a stream video from a now, and the now isn't the fastest. It doesn't have the fastest processor in the world. So I've been spending a bit of time thinking what should I do, and I might just the current approach is I might just try sending frames over gRPC because I don't really need seamless video. I just need frames fast enough that it can do something with them. So I
Yeah,
haven't.
that's true.
I've been distracted with too many other things, so I haven't. That's been on hold for a bit, but I need to actually get back to that.
Yeah.
I have a way too many different things on the go. It's actually start finishing some stuff.
Yeah, I could feel that. I had also like, oh, I have to troubleshoot reconnecting the data channel. No, but my UI is crashing. Like, no, I cannot select multiple things at the same time. Oh, I cannot have two browsers open and see the same stream. It just doesn't connect. It confuses. Oh, am I connected here? Because when I open second browser, the first one fails. It's like, oh, here is my new window. I go like too many things to work on. So thank you so much for today. Thank you for the feedback. Thank you, Danny, for putting your effort to use the system, which unfortunately didn't work really well today. I hope in a couple of months it will be more stable. I will work on the stability.
I'm looking forward to demoing again in a few months.
Yeah, I guess we'll watch this space, and hopefully, when you have the version 2, you'll come back here and show us.
Yeah. So
Cool. Well, thanks, Sasha. That's been really fun. And
thank you, guys.
Yeah, thank you. Much
Have a
appreciated.
nice rest of the day. Good evening.